parts of a right triangle. What we're talking about is just the legs and hypotenuse. When I'm doing the Pythagorean theorem, I like to put c squared off to the left, just because that helps me with problems like this. This is for a right triangle. What happens when you have c squared on the left-hand side and you see a less than symbol instead of an equal symbol? What kind of triangle is it then? Acute. And if it's greater than, when it's in that order, from c squared on the left and a squared and b squared on the right, that would be an obtuse triangle. Don't forget about those types of problems. I'm not showing those types of problems here. If you look back at the work we did in Chapter 7 in your notes, you'll see a lot of practice problems dealing with acute and obtuse. Which triangle is the right triangle? And the first one? D. 5, 12, 13 works. Jump right across to number 4. Number 4 is actually using that triangle right there. It's just oriented in a different way. We have top of the ladders leaning on a building that's 12 feet up. The bottom of the ladder is 5 feet from the base of the building. What's the length of the ladder? Well, that's this over here. Same exact problem, really. Jump back up to here. They're throwing in a lot of information, but it's still just doing the Pythagorean theorem with 7 and 8. What does that turn out to be? That's not going to work out evenly. You're going to get 49 plus 64. That will be 113. What's the square root of 113? Well, what's the square root of 144? 12. So, can't be 12. 15 is too big. My guess is that it's 10.6 because 9.5 would be too small. 10 times 10 is 100, so we know it has to be above 10. 10.6. And what are we looking for in this problem? Is this a leg or a hypotenuse?
Leg.
We're looking for a leg. So the setup would be 25 squared x squared plus 7 squared, 225 and 49 x squared equal to, what is that? Did I set that up right? I got 49. Oh, hold on, 625. That makes a little more sense. Is that 576 when you subtract that? What's the square root of 576? 24. Turn your paper over. We're going to put a proof on the back. Not a formal table proof, but more of an algebraic proof. There are many proofs of the Pythagorean theorem. A squared, b squared, c squared is what we're trying to get to. We haven't really proved it. We've just been using it over and over and over again, and it seems to work. Are you familiar with the name James Garfield? Who is that? Who is James Garfield in history? Hmm? It's kind of a, I think he was an amateur. He was president of the United States. Oh. Right? President Garfield. He developed a proof of the Pythagorean theorem. Here's how it looks. What he did, he set up a drawing that looked like this. He set up two right triangles so that these 3 points were collinear. This is a straight line. And the two triangles are exactly the same. They're congruent. But he didn't put any numbers in here. He just put letters. He said that he was going to call this A. And that's the same length as this. This and this, same lengths. Then he called this B, and he called this B, and then he called the hypotenuse of each one C. So that's how he set it up. Two congruent triangles. So every A that you see on here is the same length, every B on here is the same length, every C is the same length. And what he did was he used a trapezoid method. He connected this with this. Pulled dotted line from those 2 points. Because you got right angles here, this is parallel to this, so this is a trapezoid. He created a trapezoid. Then he just started playing with variables. Take a look at the whole thing as a trapezoid, and look at your formula sheet for the area of a trapezoid. Area of trapezoid. What's the formula for the area of a trapezoid?
Height times base 1 plus base 2 over 2.
All right, so we got, does it say 1/2 B1 plus B2 times height? Something like that. Well, what's the height of this entire trapezoid? How would you describe it using those letters?
AB.
Plus B.
A plus B? So from here to here, the entire height is A plus B. So right here, instead of height, I'm going to write A plus B, because that's what it is. I'm still going to have the 1/2 in front. Base 1, base 2. What are we calling that in this drawing? There's base 1. There's base 2. So what should I put in here? A plus B. If I add the two bases, I'm adding A with B. And then I'm going to rewrite this as, how do you write when two things are multiplying the same thing? Can we write that in terms of an exponent? Can I do that? This times this is really just A plus B squared. So we'll leave that alone for a second. Leave that off to the side. Then he took a look at the area again. He decided, well, the area of this is really this area plus this area plus this area. So he decided to take a look at what it looked like in terms of the three triangles. Put a right angle right here. How do we know that that's a right angle? put a 1 right here. We'll call that angle 1. We'll call that angle 2. Well, what angle is right here? If the two triangles are congruent, what would go here?
2.
1. Because that's connecting with the A. Down here would be the 2. So because he set up the problem where he had two congruent triangles, that's 1, that's 2, that's 1, that's 2. What's 1 plus 2 plus 90? If it's inside the triangle. 180. But it's also 1 plus 2 to make a straight line, and the only way that'll happen is if you have a right angle there. So not only do we have a right angle, a right triangle here and here, we have another big right triangle right here. So it's going to be very easy to find the area of all three triangles. What's the area formula for a triangle? Base times height. All right, we're going to write it with the 1/2 since I got 1/2 over there. So I could say 1/2. What's the base and height of this triangle? Well, it's A and B. What's the height and base of this triangle? Isn't that just A and B again? It makes sense because the two triangles are identical. They should have the same area. How would you describe the area of this big right triangle?
C times C.
C times C, but don't forget the 1/2 that goes with it. 1/2 base times height. I'm going to write it as CC for right now. So that is one way to show the area of the whole object, divided up into three triangles. This is another way of showing the area of the entire object, dealing with a trapezoid formula. Therefore, all of this must equal all of this. Let's combine this a little bit. If I got half AB and half AB, what does that combine together to form? If you got half of an AB and then another half of an AB, what do you end up with? A whole AB? And let's write this as 1/2 C squared. Put them together. This is the area of the whole thing. This is the area of the whole thing. So AB plus 1/2 C squared is equal to 1/2 A plus B squared. From here on in, we just try and manipulate this thing until it looks like the Pythagorean theorem. So let's see what we can do. I'm going to leave this side alone for a second. If I actually did A plus B, that would involve Landon, you're going.
On the third order.
Good luck.
Have a great day.
You too. What's A times A? A squared. I'm doing FOIL. This times this. Then I'm doing A times B. Then I'm doing another A times B. Then I'm doing B times B, that's B squared. All of that is being multiplied by 1/2. Let's see. All right, I don't like those 1/2s floating around. How can I get rid of 1/2?
We divide by it.
Or
Just subtract.
what could I multiply by to get rid of it? This is what President Garfield did. He took everything and he multiplied everything times 2. If you do it to everything, you're not changing the balance of the equation. So 2 times AB is 2AB. What's 2 times 1/2 C squared? What happens when you do the 2 times that 1/2? That was the whole point in multiplying by 2, was to get rid of it. And that 1/2 over there, that goes away. So now all I'm left with over here is the A squared, the AB, and the B squared. How many ABs do we have over here? He subtracted 2AB from each side, and he ended up with C squared equals A squared plus B squared.
Oh, wow.
That is a proof of the Pythagorean theorem. One of many. Courtesy of a former president of the United States. All he did was manipulate algebra until it came out.
Crap. Oh wait, never mind. I'm math as well. Wednesday, if I didn't have math as well, I would have been into math for 3 hours.
This is the last little review that I have. This is quadrilateral.
And then yesterday, the advanced computer math finals also.
Oh,
Yeah.
wow.
Just said this will last.
That's
Hey, awesome.
actually really good.
Who's like, he's the last.
You're really-
You've never heard of this. This stuff.
We could do more, but it doesn't make sense because you just took your circled test. So I shouldn't have to go over circles for students. How many people still owe me a circled test correction of that chapter 10 test? If you still owe that to me, that could be something you work on between now and your SOL on Wednesday. That would be a good review of circles. I'm going to pass back anybody who's already done their circle corrections today, so you'll have that to take a look at. I don't think we need to go over transformations. The most I'm going to do with transformations after this is just talk about algebra. How do you do a y equals mx plus b line? Because that's what people are getting wrong. They're not getting the geometry wrong, they're getting the algebra wrong. We'll go over some basic algebra. And surface area and volume, you've got the formulas in front of you. The only thing I'm going to go over is lateral area as opposed to surface area. More extra credit Jefferson Labs from some people. You got all weekend. Face it, you're not doing anything else. How's the weather supposed to be this week? Nice.
Yeah.
Whenever you go into the hallway, just be quiet because there is testing going on. Just to Saturday is nice. Sunday could be a little rainy. Could be at Jefferson. Somebody Google on your phone what president was Garfield. I don't even know what time period that would have been. What was the name of the president who died almost right after he got into the presidency? He caught a cold or something with pneumonia. No? Google that too. Do you know who the president is? Oh, okay. Who's the vice president? Nope. All right, good. Who's the Secretary of State? All right, let's get 3 in a row.